tend to review, right? And so that's why I kind of have a very strict timeline that I try to follow. Go to page 10. So now we're going to talk about Venn diagrams and how do we call each region, right? And some terminology. If you ever see that notation, A intersects B, that's how we call it. So that's an intersection. Intersection of A and B. The key word when it's intersection is and, okay? We're interested in elements that are in A and B, that are doing both, right? Students that are in applied and biology, and, right, in between. Intersection, they mean the same thing. So just so you know, the pattern is, if you look up here, the first image in every single one is going to be a joint set scenario. The second one is a disjoint or mutually exclusive. I hope you know what that means, ME, right? Mutually exclusive. And what do we call this? If one is inside the other? Starts with an S. Subsets. So disjoint is an empty set. There's nothing. In this case, you don't have any elements that are in both, all right, guys? So nothing gets highlighted here. When it's like this, you would only highlight this. The elements that are in B are the ones that you would say are in both. And I would like to add under the disjoint, the middle here, at the bottom, just say that A and B is an empty set. Empty. Okay, no, there's nothing in there. The next one is union. I'm going to use the different color for that one. So the other one was facing down. It's almost like an N for and, right? This one is facing up. It's almost like a U. It's or. We call that union of A and B. And the key word is or. The elements in A and B are combined, but not repeated. Okay? Yeah, go ahead. So, or, okay? So, in this case, it would be everything that's in either one of those. I'm not going to highlight the whole thing because that bleeds through. Then you can't see what's on the back side. But it's everything in either one. So we're talking about students that are in applied or biology, meaning it could be only in applied, it could be students that are in both, or it could be students that are only in biology. It doesn't matter. We would just include all of them. In the middle case, when they're disjoint, well, guess what? You still only care about what's in here and what's in here. I don't know. It's so tempting to just do this after all. Sorry, guys. Otherwise, you might think like, oh, is it just what's close to the edge? No, it's everything. Okay. The subset scenario, we would just highlight, again, both sets. That's the union. It's crooked, eh? There we go. That's better. Should maybe get some pencil crayons. Maybe that's better. And then the last one here, I'm going to use green on that one. A/B. And what that means, in a sense, is A minus B, but more specifically, elements that are only in A, not in B. So in this particular case, you only care about all the elements that are in A, like just the applied students. How many are only in applied? That's what we would want. Even though A extends, right? A extends into B here. There's an overlap. I don't care about that. We just want whatever is in A. So this would be A / B is this section right there. Same with this one. Obviously, they're disjoint, so this one is easy. We would only care about the elements that are in A. Let me bring this up a little bit for those that are in the back row. And then here, if you only want A, what would I do? I would highlight everything except for B. Okay, so that's what it would look like as a Venn diagram. And of course, we're going to have to talk about when it's not a Venn diagram. Next, A with a little prime on top, A prime reads all elements that are not in A. I want you to have the alternative and I know I've seen online, I've seen variations of this. So I will just say this. If a letter for a set has some sort of tick or bar or anything, it's not. Okay, it's the complement. Okay, so we're going to use orange. Okay, so all elements not in A, that's what that means. Okay, so in this particular case, you want to make us, you want to highlight around A and then take the universal. Okay, so you would just want whatever's outside of A. This is the complement. That's what not A looks like on a Venn diagram. So it may include outliers, but basically anything except for A. That's basically what you're saying here. Over on this other one, we're going to highlight around A like this and the box. So it may include outliers if there are. There won't always be outliers, folks. Sometimes there aren't. But it's essentially everything. What about the last one? What do you think? It's you go around A and you highlight the box. My orange is running out of steam here. But Mr. Erickson, couldn't we highlight B? Because it's B, right? But B is inside of A. You know what I mean? So you can't include it. Like you have to, in this case, you would just also have to omit B because it's inside of A. So sometimes I'll ask you to do that. I want you to use I want you to have this one consistently. If I ask you for the number of elements that are not in A, you will take the number of elements that are in total, like available to us in the universal, and go ahead and subtract whatever is in A. Okay, so that's number one. Let's go up here, and I'm just going to say, where do I want to add this? I feel like I want to add this under the union part here. So let's zoom out to the union part right here. And I'm going to introduce the the way we refer to the outliers is written, like in this case, it's A and B that we're talking about, right? So you go A or B, not. Or N, A or B with a little tick at the end. Anytime there are outliers, the notation to refer to them is this. And think about it. Think about it up here, the purple. If I go A or B, it's all of this. I don't want that. Well, what are you left with? Outliers, right? So that's the notation. I would strongly suggest you add this to your study sheet as well. I would say for now, maybe wait a little bit as to, like, don't add this whole thing on your study sheet because it might take up way too much space. I would honestly say that, like if you want this on your study sheet, I would maybe not include the joint or disjoint sets. I would just have like most of the time you have them overlap. So if you understand the notation and what it looks like on a Venn diagram, and you can just use pencil, right, to shade in, then you're good. All right, let's keep going. This part right here. We're gonna talk about pi. No, not that kind of pie. Not the one you want to eat. But we're going to talk about principles of inclusion and exclusion. So this kind of governs all the reasoning we're about to do, guys. That short is pi. We're going to start with 2 sets, then we're going to go 3 sets. This area right here, what do we call this again if it's a backslash? Only A, or you can say A but not B. So I'm going to give that a color. It's like a half moon or something like that. I want you to write down that how a word problem can refer to it is only A, but not B. And make a little bubble, like a cloud. Right? So what would we call this one, on this side? This region. Notice that it's just flipped, right? The B is in front, so this region right here is B, but not A. I like to refer to it as only B, or B, but not A. Have a little cloud there. If you're at the center, both A and B. I don't know why, but I'm just going to use applied and biology. Students that are taking both applied and biology. And the outliers, I should have probably done the notation there. If you just want the elements, you take the union and you put a little tick on it. That's how we refer to this region right here. Oh, I'm going to give the middle a color as well. It's important to have colors. Scrambling. Okay. Don't do this to us. We're going to have number of elements most of the time, unless you have words in there. So if you wanted to put a number here, you would have to add anything that's in the green plus anything that's in the orange. If you wanted to have a number for set B, because remember, B spans into A like this, right? Because there's an overlap. So you'd have to go the orange plus the purple. If you don't have colors, maybe have subsections like maybe call this area 1, area 2, area 3. And then you go 1 plus 2, and this one would be 2 plus 3, or something like that. Just have subsections. Okay. And now we get into these ones I want you to have on your study sheet based, and I would like to have a Venn diagram that goes with these ones. All right, let's go to the bottom half of this. I'm going to try to keep them all on. It's not working, it's not working. Almost working. Okay, I'm gonna, oh, it's almost over, right? I'm gonna stop. I know you're